Good afternoon, everyone. We are the girls who code of South Street School. Today we will present to you our Soil Moisture Project. Our Soil Moisture Project is about helping our community having a chemical-free food, plants. Our code works by detecting the water in the soil of the plant. The microbit will detect if water is needed or not. We take pride of being the only school that does physical programming. Hi, my name is Tyler.
Hi, my name is Nevaeh.
Hi, my name is Rachel.
Hi, my name is Carla.
Hi, my name is Azaria.
And this place is going to be our future rooftop garden for South Street School. Come on in. The South Street School community will be very self-sufficient. We will grow our own food,
Free of chemicals and organic.
As you can see, this is a beautiful place where we have a lot of access to sunlight, and these containers will be our future places to plant our plants. We have 1, 2, 3, 4, 5 big containers which we will be able to plant plants like tomatoes, lettuces, cabbages, green beans, and so much more.
So for our rooftop garden, we did some coding. The coding is to figure out if the water
if the soil needs.
If the soil needs water or if it does not. It'll show a certain number when the soil does not have enough moisture, but it'll show another number when the soil has enough moisture.
Okay, yeah, so the thing that it's gonna show is a microbit, which is where the data is gonna put onto, and when the nail is put onto the water, the soil, if water is detected, the microbit is this little thing, and it's going to show if the whole red little LED lights are turned on, that means that the soil moisture is good to go. And if it's only a little bit, that means that water needs to be accrescented to the plants. During our spring break, we had to find a way to keep our plants that we use for a science experiment to keep it hydrated and healthy. So we coded it.
Come on back inside, let's talk about the code.
This is the design process. Define the problem, generate concepts, design a solution, build and test, evaluate the solution, present the solution. Define the problem. We need a way to water our plants when we're not here. Generate concepts. We coded a microbit to tell us when the soil needs water. And then we made an automatic plant waterer. And then we coded a program that will automatically water our plants when we are away. Design a solution. Then we designed and built a prototype.
Soil moisture explained. The soil itself has some electric resonance, which depends on the amount of water and nutrients in it. It acts like a variable resistor in the electron circuit. The water is not conductive, but the nutrients content is. The combiner of the water and the soil nutrients makes the soil have some conductivity, so the more water there is combined with the nutrients, the less soil will have electricity present. Pin 0 or P0. The P0 pin returns a value between 0, no current, and 1023 maximum current. The value is graphed on the screen, which we coded to let us know when the soil was too dry or too wet.
From the Soil Moisture Project, we know that the moisture is low when the reading is roughly less than 500. We can use this number to add an if reading is less than 500 in the code to detect the dry condition.
This is where the reading is less than 500.
The servo is connected to pin P2 so we can use the servo right block to change the angle of the servo. We want the angle to change to a 0. Wait until the water pours off and then move the angle back to 80.
We're testing the servo value right here.
The idea is if it works on the simulator, it will work when we download
it onto the mic.
when we downloaded it onto the microbit.
How's it going to say?
Pretty.
Have you ever wondered how we get the code from the computer to the microbit? First, we download the code after we tested it on everything. Then we get the code, we drag it onto the file button down on the bottom. We open it, then we drag it to the bottom, open it, and we drag it to where it says the microbit code X. There. After we get the work on the computer downloaded, we go and we plug in the microbit into the computer. But after that, we don't need that anymore. We have a battery pack that we can plug into the microbit, and we could make it work without having to use the computer. Once it's downloaded in the microbit, it's a mini processor and it can make stuff work. It does take a little bit to process, but in a few seconds it will start to work.
I'm on a battery pack and my code is already ready, set in the microbit and ready to be plugged in.
With the battery pack, it worked.
Build and test. We built and tested. Guys, I wasn't ready.
Oh.
He wasn't ready. Build and test. We built and tested our own prototype. Oh well, back to the drawing board. And that's how you code something to make it work in the real world.
Thank you for watching Girls Who Code, and we are South Street.